Okay, so this is our last topic. So this is less in this unit. So this is lesson, I think it's lesson 12. Wow, that's what I think it is. So, estimating surface area and volume dimensional changes. So we're estimating dimension changes. And so we're using estimation. Okay, estimation is a great skill because what it does is, if we're able to estimate, it allows us to understand if our answer makes sense or not. So let's recall, a referent is something that's familiar to you, an object or part of your body that helps you estimate the length or size of things. For example, we can use the length of our forearm to estimate 1 foot and the width of our pinky finger to estimate 1 centimeter. So we can have these estimational reference to help us estimate things. I often, like if you're saying, oh, how many feet across is this room? You use your own feet just to kind of get an idea. If you don't need to be precise, it's a good approximation, okay? So let's think about some possible reference that we can use for the following area measurements. So for a square inch, what we might look at is for an inch might be, so it might be the width of your thumb. That might give you for an inch. So a square inch might be maybe a bubblegum wrapper, or no, you know what might be a good square inch is a Starburst candy, okay? Just something that might be a good approximation for a square inch. Might not be exact, but it's a referent that gives you an idea. A square foot, maybe a floor tile, or a textbook cover. And you may say, oh, miss, my textbook is not square, but it might be close enough that gives you kind of an idea of how big a square foot is. A square yard, maybe a tabletop, like a kitchen tabletop. Perhaps, half a door. Okay, again, they're not exact, but they might be close to give you kind of an approximation of what we're talking about. Square millimeter. Well, that's rather tiny. So maybe it is like the head of a pin. If you think of a pin, has a very tiny little head on it. Okay, so that might be a square millimeter. Something very, very small. Not as small as a pencil lead, but a little bit bigger than that. Okay. Square centimeter. Well, look around. Maybe your keyboard key. That might be a good referent for a square centimeter. Square meter, similar to square yard, a tabletop or half a door, desktop. Gives you a sense of your square meter. So those are reference. Okay, now we are using these references to estimate. Okay, the Oilers are going to produce stickers to hand out to kids for the next game. Estimate the approximate area of one of these stickers as shown below. What units make sense to use? So now I have a ruler, but I'm just going to kind of map out the size of this. My ruler's not going to be exact anyways because my screen is not exact, okay? So it's interesting for us in terms of kind of looking at this. I'm looking at it on the screen. You're looking on your page. I'm assuming I'm close to 100%. when I look at this, I think, well, if it's a sticker and that's about the size, I'd probably want to use centimeters squared. And then looking at this, I could probably break it into approximately 3 by 3 centimeters squared, right? So 3 by 3 would be approximately, and I'll use that, centimeters squared. So it might be 9 centimeters squared. Might be a little less, might be a little more. But I don't think more, though. I think more would be kind of big. So maybe we say it's like 8 to 9 centimeters squared. It's an estimate, right? But thinking about what units make sense. If each of these is 1 centimeter, 3 centimeters, that's a good fit, okay? And again, we're estimating. The front of a binder is about 1 square foot. Use this information to help you estimate the surface area of your teacher's desk. So what you're going to do is think about how many binders we could fit on your teacher's desk. So I have a fairly wide desk. I think I could fit 1, 2, 3, 4, 5, 6, 7, and this would be about a half a binder. Okay, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9 binders, approximately. So that would be approximately 9 feet squared if I did that. Now, you can do the same thing at home. Your desk, it might be a bit smaller than mine, it might be a bit bigger. It really depends on the size of the desk, right? So if we're doing that, now that's the top. I did not do this once, the surface area. This was just the top. So you would also use the binders as kind of measures for the rest. So what I would do is kind of estimate that using your own desk to kind of sort out exactly how much you could cover with it. Okay? These are a little trickier to do in that we're doing online learning. Now, instead of using a classroom for here, what you're going to do is you're going to do your bedroom. So 1 gallon of paint covers 200 square feet of wall space. About how many gallons of paint would you need to paint all the rooms in your bedroom? So what I want you to do is I want you to think about how many, using that idea of the binder, number of binders, and then once you figure out the number of binders, that's your square feet, right? So that's your feet squared. And 1 gallon of paint covers about 200 feet squared, so you would divide by 200 feet per gallon, and then you would get the number of gallons. And it's going to be different for all of you because you're going to have different size bedrooms. And it's an estimation, right? Okay. All right, estimating volume. So for this one, I want you to do your own desk. The whole surface area, I just did the top of, this is the teacher's desk. So you're gonna do your whole desk, and for this one, you're gonna do your bedroom, okay? Ooh, estimating volume, reference. Discuss and identify appropriate reference for the following volume measurement. So volumes are a little different because it's cubed. So a cubic inch. So we want to think of something that's 1 inch by 1 inch by 1 inch. Maybe a dice. Okay. Or a wooden toy block. Okay, getting a sense of that. Cubic foot, so a foot by foot by foot, maybe a gift box. If it's a big gift box, right? Or perhaps a bag of potatoes. Doesn't have to be rigid. okay? This would be a big bag of potatoes, right? Not just a little 5-pound bag, okay? A cubic yard. So we're thinking something that's going to be a yard by yard by yard. Maybe a recycling bin or a compost bin or a garbage can. Okay, I'm thinking about garbage for some reason. Gallon. Now here we're talking capacity. So a gallon, we're probably talking something like a milk jug, right? And now we often talk about gallons in terms of gas as well. So, but they're usually going to be bigger, like a jerry can is going to be bigger than just 1 gallon. It's usually about, 5 gallons. So like a jerry can might be 5 gallons. But a milk jug might give you a good estimate. Cubic millimeter. Maybe one of like those Nerds candies, right? Or a cupcake sprinkle, right? Cubic centimeter, sugar cube, or a jelly bean, right? A cubic meter. So this is a little bigger, right? It's close to a cubic yard, but maybe something like a dog crate or dog kennel, or a small shipping crate. Okay. Liter, also talking about capacity. I don't know about you, but I have 4-liter milk, but you can get 1-liter milk, right? So if you think about those 1-liter milk containers, that gives you a good idea for how much a liter is. Okay, so let's talk here. What units be reasonable to estimate a book? Well, a book, it's too small to really use something like meters, but you might want to use something like inches cubed. Remember, we're doing volume, right? So it's cubed, or centimeters cubed, since we are in Canada and we use the metric system. Railway car. Well, you could go foot cubed, but they're actually pretty big, so it might be meter cubed or yard cubed, right? A queen size mattress. I think you would use feet cubed, because I think if you use meters cubed, you would have a partial, like it would be less, like it smaller than that, right? I think feet cubed would work for that. And centimeters cubed or inches cubed, it would be a really big number. So I think feet cubed would be good for that. Coin, like a quarter. Well, a quarter or a loonie might be centimeters cubed, but I don't know. I think you're more likely to use millimeters cubed for that, because it's pretty thin and we're talking volume. I think if you're doing surface area, you could do centimeter squared, but I think you would use millimeter cubed for that one. Estimate the volume of a typical cell phone using one of your reference. What would be a reasonable unit to use? So this is something for you to do. So write to do, and you're going to estimate that volume using one of those items. Maybe a jelly bean or sugar cube, because I think it would probably be centimeters cubed. Okay. Surface area, exploring dimensional changes. So sometimes we have to think about what would happen to our volume and surface area if we changed one of the units. So take a look at this rectangular prism. How would its surface area change if one or more dimensions are changed? Well, let's figure out our surface area to begin with, right? So our surface area is going to be, we've got 2 of one size, so this is 4 by 7, 2 of the next side, 5 by 7, and then 2 of the last size, 5 by 4, okay? So it is 2 times 4 times 7 plus 2 times 5 times 7 plus 2 times 5 times 4. So surface area, we total all those up and we get 166 meters squared, or inches squared. Why did I write meters? Because it looked like a meter on my notes. Okay, how would the surface area change if one length changed? What if we test this? Change 4 to 8 inches. So we're basically doubling it. Well, looking at our formula, everywhere we have a 4, we're going to write an 8. So 2 times 8 times 7 instead of 4 times 7. The middle one stays the same. And the last one changes 2 times 5. It becomes 5 times 8. So when we multiply those through, we'll get, here we'll get 112. This will stay the same, 70. And this will change to 80. So basically the 112 and the 80 doubled. So we get 262 inches squared. So obviously it's going to increase, but it's not a predictable increase. We know that this one and this one doubled, but the middle one stayed the same. So these ones doubled. But the middle one stayed the same. How would it change if all dimensions were doubled? Well, that's going to have quite an impact, right? So let's take a look. So if I take my original value, 2 times, well, I'm going to double everything, right? So it's 2 times 8 times 14 plus 2 times, oops, if I scroll down, 10 times 14 plus 2 times 10 times 8. So I get the 8 times 2 times 8 times 14 is 324. 2 times 10 times 14 is 280. And 2 times 8 times 10 is 160. And I get 664 inches squared. Well, this is actually 4 times the original. If you take the original 116, you're going to get 4 times bigger. So if you double the dimensions, all of them, surface area gets 4 times bigger. Okay? How would the surface area change if all were tripled? Well, that's an exploration, right? So if we substitute that in, so you're going to go surface area equals 2 times, well, instead of 8, we'll have 12. Instead of 14, we'll have 21. Plus 2 times, instead of 10, we'll have 15, because we're tripling the original, which was 5, times 21. And then 2 times 15 times 12. We multiply that all through. We get 504 plus 630 plus 360 equals 1494 inches cubed, which is actually 9 times bigger. So if you triple all, you get an increase by, not 2 times, sorry. I don't know what that's about. 9 times the original. Okay, so from that, what's going to happen when we quadruple? Well, let's think about it. It's 4 times, so it's going to be basically 4 squared, which is 16 times. Okay, so we can draw that conclusion. Alrighty. So, the next two I want you to do and we'll come back and do them on our own, okay? And then I want you to try the next one, okay? Oops. So you have to do a little bit of exploration there to kind of see what's going to happen, okay? Little bit of exploration questions for you to practice with. Alrighty. I'm going to make a second video and we'll come back and we'll do those after we do the second video, okay? So to do, I want you to try